Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. Today I will show you a simple O of n solution which is very easy to code also. And this problem I will say is not at all difficult. You should definitely try it on your own first and then continue with the video. Okay, so let's see the problem. Maximum fruits harvested after at most k steps. So fruits are available at some position in an infinite x-axis. You are given a 2D integer fruits where fruits of I denotes position and the amount. Okay. So at position I, let's say what does this 2 comma 8 means? At position 2, there are 8 fruits present. So at position 2, there are actually 8 fruits. And this 6 comma 3 means at position 6, there are 3 fruits present and so on. So this is what the fruits array means. And start position is the position where you are starting from, and k is the number of steps from by maximum number of steps which you can take. Okay, you might go to right and then again go to left, something like that. Okay, so the k is the maximum number of steps that you can take, and you need to output how many fruits can you collect. So if you go to left and position 2, you could have collected 8 fruits. Okay, but if you go to the right 3 steps only, you could have collected 3 + 6 9 fruits. Okay, so 9 is more optimal definitely. And if you go to 2 once, you cannot come back to 6 because you can take only 4 steps, cumulative of 4 steps. So that is not possible. So I hope you understand the problem definitely. Okay, I hope you easily understand the problem and there should not be much difficulty in understanding it. So yeah, let's try to let's try to see what is the what can be the possible approach, or how to how to start thinking this problem. Okay, so what to do? You are given an infinite number line on which, let's say, from this point you are starting. Okay, and you can perform some steps. You can go to right, you can go to left, and some things. So can you first I mean tell me what are the possibilities which you can traverse, and while traversing in your path, whichever if there are some fruits here, you just keep collecting all the fruits in your path while traversing. Okay, that is also pretty obvious. So can you tell me what are all the possibilities of traversal, what are all the ways of traversal, and how, among all the ways, which of these do you think is feasible? So, okay, so what do I mean by it? Let's say first way can be of taking 0 turns. I will take do not not take any turns, so I will move completely to the right from my start position. Okay, I will move k steps to my right. This is starts plus k. Okay, k steps I just move to the right. This can be a possible by taking 0 turns. Okay, 0 turns. So I will just increase the turn number. Now, starting from right, starting from start, you can go to left k steps. Okay, this can be a possible way. Okay, so these two use 0 turns. Okay, now you can try to do 1 turn. So let's say you move x position to the right and then again move something like k minus x position to the left. So you are taking 1 turn here. So let's say you do something like this. Okay, and let's say now you do something like this. You move here and then again move here. Okay, now you, let's say, do something like this. You move more to the right and then move less to the left. Do you think this is feasible? Okay, so let's see what are all the possibilities. And there can be more approaches, right? You can maybe go to right, then go to left, and then again choose to move right. Okay, so let's say you choose to move right and again collect this. Okay, because these, if you are moving this position, you have already collected, and so you definitely want to move to the right and do something else. Okay, so this can be, and there can be many other possibilities. So how many of these possibilities do you think is favorable? Okay, so what do I mean by favorable? This can be favorable, there is no doubt about that. You can just keep going right. This can also be favorable because you can just keep going left. There is no problem with that. Okay, and so what were the ways actually? This was I how was I classifying these? These were using 1 turn. Okay, all these were using 1 turn, and these all use greater than 1 turn. Okay, So, mm, uh, can you think that whether this can be possible? Yes, this is possible. Can you think whether this is possible? Yes, this is also possible. Do you think now that this is possible? You see, as you went from this point to this point, you collected all the fruits, whatever were the fruits in the middle. So there is no point traversing again to the left, and that too with a small value, because these fruits you have already collected. So there is no requirement of this. So what does this say? If I move to somewhere to position, right position, then I should move to the left. If I'm taking one turn and moving to the left, then I should be moving more than that. Okay, so I should can be moving a little bit more than that. Okay, so my first step is, let's say x, this is, let's say, k minus x. So x should be maximum till k less than equal to k minus 2, k by 2. Okay, I hope you understand this, because total step is k. Okay, so let's say this is k and this is k by 2 and k by 2. Total steps you can take k. So what will happen if you will move k by 2 steps to the right and k by 2 steps to the left? Okay, this is just the edge case. You need to do something which is just more than this. So x has to be less than k by 2. X has to be less than k by 2, and then you can move somewhere to k minus x. Then this whole position will be greater than k by 2. Okay, so I hope you understand this. X can go till k by 2. I hope this much intuition is very much clear to you. So this is okay. Now, do you think taking more than one turn is at all feasible? Let's try to visualize it more clearly. My, I mean, if you have a good intuition, you can definitely say that taking one more than one turn is not that good. Okay. So, how to prove that? Let's say you are doing something like this and you go to this. Okay. So let's say this distance to this is A, this to this is B. Okay, this distance is A, this distance is B, and this distance is C. Okay, so let's say you have used K steps in doing all of this, and you move something like, you started from this. So what is the steps now, amount of steps which you have moved? So you have covered all the fruits starting from this to this range. Okay, but what is the number of steps that you moved? You moved something to the right. Okay, you started from there, you moved to the right, so you took B steps. Okay, then again you move from this point to this point. Okay, so you moved A plus B steps, B plus A in fact. Okay, then again from this point, you move to this point. So you take A plus B plus C steps. Okay. And you ended up in covering all the fruits from A plus B plus C range, this range. Okay. But wouldn't you have also done something like this? Let's say this is again A, this is again B, this is again C. Couldn't you have done something like this? You started from here, right? You go to C at together only, and then you come to A. Then you come to A. What is the steps moved in this? So what was the steps moved here? You moved 2A plus 3B plus C steps. Okay, by taking two turns. Now, by taking just one turn, you moved only B plus C plus A plus B plus C. I hope you get it. B plus C because you move from this to this. A plus B plus C because you move from this to this. So you did something like A plus 2B plus 2C. Now definitely this value is 2C. Okay. So definitely this value is less. If you compare these two values, this value is less. Okay. And both of them covers an equal range of fruits. Both of them moves from covers the range of A plus B plus C. So by covering equal ranges, you can take minimum steps. If you take one turn, and if you try to take more than one turn, you ended up in taking more number of steps. So it is always optimal to take one turn. Okay, always optimal to take one turn. Now, can you generalize this? Can you somehow generalize this? What do I mean by generalizing? Let's say you can tell me that I have two choices to be exact. Okay, I have exactly two choices. I can move x units to the right and k minus x units to the left. Or I can move x units to the left and k minus x units to the right. Only these two choices I have. In the case, now you will say that where is the case when I am moving completely to the right or completely to the left? Those cases are hidden here only. What if x is 0? Then you completely move to the right. What if x is 0 here? Then you completely move to the to the right here. This you move to the left and this you move to the right. If x is 0. So within these two choices only, my whole possible number of ways, my all possible number of ways are getting captured. So I have just two choices. So the main thing in this problem was to observe this, that you have only two choices. Now, as you get something like this, so what will be the ranges? Let's try to calculate the ranges. Okay, let's say you start from position, let's say start pause. Okay, you have this position. Okay, start pause, something like this. And so what did I tell first? So case one, you move first left. Okay, so you move this is the case one which I'm talking about. So this is x, this is k minus x. Okay, so at first, where did you move exactly? At first, where did you move? You move to the right. Okay, so after moving to the right, what will happen? Start pause will get changed to start pause plus x. Now, from this point, you are moving k minus x to the left. Okay, from this point, you are moving k minus x to the left. So start pause plus x. Okay, from this position you are moving to the left. Okay, so you are moving to the left, k minus x. Okay, so this is what will be your range. You can cover from this to this. Okay, so this is your range r and this is your range l. So this is your range r and this is your range l. So you covered all possible fruits from range r to l, l to r. Okay, l to r. Okay. Now what is the next case? What can be the next possible case? Case 2. In case 2, let's say you move left first and then right. Okay, so you move x and then k minus x. These points. Okay, so what can be the possible way? First, you are at start pause here again. Then you move to the left. So you move to something like start pause minus x. Then you move to something like start pause minus, from this minus x, you are adding k minus x. Okay, you are moving k minus x to the right, so you are adding k minus x. So this is nothing but your l value and this is nothing but your r value, and again here also you move from l to r and you cover all possible fruits from l to r. Now, what can be the possible iteration values of x? So as I told you, there is no point of moving more and then moving back less. There is always point in moving less and moving back more. Okay, as I have already explained you, because moving less means you are covering the positions where you have already covered the fruits. Okay, so there is no point of doing this. So as I had already explained you, this x value can be up to k by 2. Okay, this x value should be less than equals to k by 2. So while doing all this, I can simply do a for loop which goes from x equals to, let's say, 0 to x less than equal to k by 2 x plus plus. I can easily do this, and in this loop I can simply calculate this range. Okay, so for both case 1 and case 2, so inside this loop I can do something like case 1. Okay, case 1 I will calculate my l and r in the formula which I told you. Okay, and then again for case 2 I will calculate what is my l and r. Okay, and then I will update how many fruits. So let's say I will have an answer variable. Initialized to 0. I need the maximum fruits. So I will just update in both of the cases. Okay, so in both of the cases, I will just update this thing. So in both of these cases, I will just update the answer, which will be nothing but maximum value of answer, comma. How many fruits are there in the range of L to R? Okay, so how to calculate this exactly? How many ranges of fruit? That we can easily do using a prefix array. Okay, so if you don't know exactly what is a prefix array, You can just Google it out quickly. It is very simple. I will just tell you very quickly. So it can give you range queries. It can give you answer to range queries. So what do I mean by it? If you have an array like 2, 3, 6, 1, 8, something like this. A prefix array is nothing but you add this 2 with 3, 5. The second element will be 5 plus 6. The third element will be 11 plus 1, 12. The last element is 20. So this is nothing but prefix array. What is the use of this? It can give you, let's say you are having an index L to R. Okay. So let's say L equals to this and R equals to this. You want to find all possible sum of values from this L to R. Okay. So what you can do, see, what is the sum of values? 3 plus 6 plus 1. So if instead of iterating every time from L to R, what you can do, you can directly get it by doing 12 minus 2. Okay, so it's something like pref of R minus pref of L minus 1. Okay, so for getting correct indices, what we do often is that pref of R plus 1 minus pref of L. We generally calculate in this way prefix array. So you just search about prefix array if you do not know. Okay, so this 12 minus 2, you can see that is also 10, which is nothing but this sum. Okay, instead of summing it every time, you can just subtract it and construct the prefix array only once. So this is all for this problem. Okay, this is all for this problem. Let's try to see the coding portion. Okay, so what did I tell you at first? What did I tell you at first? I just explained you the cases and just told you that there will be something like this. Okay, so at first, definitely I need to construct the prefix array because I need to calculate the L and R ranges also, right? So let's see. Okay, let's do something like fruits dot size. Now, what will be the length of the prefix array? Okay, so it can go till the rightmost position. Now, what can be the rightmost maximum position? What can happen is that you have a start position and you can go till k to the right. Okay, I am finding the rightmost bound here. Okay, so I am doing nothing but finding rightmost bound. Rightmost bound. Okay. Because we need to initialize the length of the prefix array also, right? We cannot just go do it just like that. Okay. And otherwise, what can be the length? Uh, fruits of n minus 1, 0. Did you understand this? Did you understand this? What did I do here? I am telling that what is fruits of n minus 1, 0? It is the last element. It is told that fruits is already sorted. So it means that the last element is x 8. Okay, and that is giving me the rightmost bound. Okay, that is giving me the rightmost bound. But definitely among both of them, whichever is the maximum, that will be my answer, because I can have a start position of, let's say, 7 and I'm moving k steps to the right. So then I will go to, in this case, 11. Okay, 7 plus 4, 11. So I may exceed this last index also. So that's what I need to initialize the rightmost bound. And now I can just simply create this prefix array. Okay, so I will just create this prefix array. So I will do a one based indexing. So that's why I will take max plus 2. So it means that uh, my array will, for position 1, my array will be, for position 0, my array will store at index 1, and for position x, for position max, okay, my array will store at index m minus 1, mx plus 1. So if in index, uh, I mean, one based indexing, I hope you know already. Okay, so and the first position we will keep always as 0. Okay, first position we will keep 0 for calculating this prefix ranges. Okay, for calculating some prefix ranges like this way. Okay, so let's see. uh I hope you know already what do we do in prefix array. So less than, what will I do? I will first put the position, put the fruits in the position. Okay, so I will just go to the fruits and I will just do this is position. Okay, so what is the position? Position is nothing but fruits of I 0. Okay, so first one is the position and this is the value, is nothing but fruits of I1. Okay, so this is a value. So what you can do in the prefix array, first you go to the position and put the value. Okay, value means number of fruits. Okay, so you just go to the position and put the values. So what you can do now is very simple. You can just traverse and build the actual prefix array. Uh, Okay, so you can just simply build the actual prefix array, which is nothing but prefix I plus equal to prefix I minus 1. So I will take the last element and just add it. I'll take the last element and just add it. So this is what I do. Okay, I'll just keep adding the last element to my current value. So I hope this is clear to you. Okay, so this is pretty clear. Okay, you can just write this in a single line also. Yeah, so you have this prefix array ready. Now, what you can do, you can simply simulate the whole thing which I said. You can go from x and go from x to k by 2 x plus plus. Okay, so that this is nothing but this loop. Okay, so this loop which I am going through is this thing. Okay, for x equal to 0, x less than equal to k by 2, I am going, how much I will move, how much I will move to the right and then to the left. So, okay, so let's say I am first moving to the right. Okay, so R1, what will be my R1? L and R, the range I am just finding out. So I am starting from this position, start pause. And if I move x units to the right, so that means the plus x. Now from this R, I am moving to the left. I am moving to the left. So I am currently at this position, start pause minus plus x, and I have k minus x steps remaining, which I move to the left. I move k minus x steps to the left. Okay. So I hope you get this easily, and that's all. And for R2 also, let me calculate both of the ranges. From the start pause, I am going to the left x index. Okay, so I am going to the left x index. And then from that, this is then L2. Okay, so and this is R2. So at first, then I after moving to the left, then I move to the right. Okay, so I move just k minus x in positions to the right. So I hope you get these easily. This is not at all difficult. And for this position, I will do just position plus one because of one based indexing. I was just forgetting it. It is just simple one based indexing. And I hope you also easily know how we can store in the prefix array. So I will have simple variable answer initialized to 0, and I can simply update my answer every time. So yeah, so prefix of r plus 1 minus prefix of l. So this is nothing but 1 and 1. So I already told you how prefix arrays work. So this line should not be a difficulty to you at all. This line should not be a difficulty to you at all. And we are done. Okay, we can just simply return answer. I hope you easily get it. Okay, I hope you easily get it. This is not at all a difficult problem. So let's try to run it and check if we have done some error in between. Okay, so we are getting some wrong answer. So let's try to analyze that. Where exactly did we go wrong? So we have the start position plus k. We fix the rightmost bound among both of these. I do prefix of mx plus 2. So yeah, and I start from these positions. I place the values here. Okay, and what can I do is that I iterated through this from I to maximum plus 1. Okay, so I just build the prefix array completely, and I just initialize my answer to 0, and I just made this L and R. Okay, and I was simply doing okay. So you see, this is R equals to 2 and this is L equals to 2. Okay, so R1, L1 to R1. This range is nothing but L1 to R1 and this is L2 to R2. So I just copied it, okay, without changing this 2. So that was the mistake. If I try to run it now, will it work fine? So you see, it is giving an accepted. Let's try to submit it and check. Okay, it did give me a runtime error. Let's see what exactly is my mistake here. Okay, so you see, there is a mistake here because L1 and R1 can be out of bounds also, right? What do I mean by out of bounds? This prefix array is from 0 to maximum plus 1. Okay, so there it can be an out of bound value. So what can I do is that I can just clip the value, the rightmost value, I can clip it to maximum. Okay, so what can I do here is that I will tell that uh, maximum value, clip it to the maximum value. Okay, and what you can do here is simply clip it to 0. Okay, so if it goes below 0, I am telling that if it goes below 0, clip it to 0, the L for the L value. Okay, and if it goes above mx, if it tries to go something above maximum, okay, so then just clip it to the maximum value. Okay, that is all, I guess that would be all. Uh, let's try to now run it and check. You see, we have the accepted case. There might be a 40% bits only, but you see, we are ahead of most of the users. But this is a little dubious because you can see we are using a simple loop. Okay, there is not at all difficulty. It is a simple linear solution. So it is nothing but O of simple 2e5, I guess. You see the constant, whatever is it. Okay, so yeah, that's all. That's all for this problem. This is a marked hard kind of problem, but it is quite doable. So yeah, that's all. That's all for this video. I will meet you in the next video, and I hope your day goes very easy. Thank you so much.